Responsible for more high-speed rail tracks than the rest of the world put together, China's high-speed rail system, known as Gaotie, is the object of envy for many countries. As the wheeled trains dominate China's 35,000 kilometers high-speed rail network, a magnetic levitation train prototype is pushing ground speeds to new levels.
那现在的世界纪录就是日本创造了603公里每小时。
我们的技术完全可以跑到更高的速度。
Could this be China's next super train? When you see a machine with curves like this, you know it is born for speed. A full carbon fiber body weighs under 13 tons, can completely float above the tracks, so light even a little girl can push it forward without much effort. All of this work for one collective purpose, to get rid of any resistance that slows the train down.
因为在我们这个车的高温超导磁悬浮车，它就自动悬浮了。悬浮上面的它将来运行的阻力主要来自于空气阻力的。
An aerodynamic shape, or the bullet head, is a widely popular design among high-speed trains, but not as aggressive as this one, as this very train was designed to hit a speed of 620 kilometers per hour. Maglev trains aren't a novelty. 6 commercial lines are in operation around the world, 3 of them are in China. But this prototype is using a new method to levitate. Superconductors, unique materials that can completely repel magnetic fields and therefore float above the magnetic tracks. To create such a material, scientists need to cool it down to a temperature near absolute zero, or negative 273 degrees Celsius.
所以说用这种特性的话，就想到应该可以让它做磁悬浮应用。就日本1962年就开始了这个叫低温超导磁悬浮研究。首先，车里面采用的是这个低温超导磁体，那它需要采用这个更低的温度的冷却，具体就是指这个液氦这个温度，就是零下269度。
Till this day, liquid helium is still very expensive to acquire. But when China kicked off its research on superconductive maglev in the 1980s, there was a giant leap in the industry. A class of materials was discovered to achieve superconductivity at negative 196 degrees Celsius. That's warmer than absolute zero, so it is known as high-temperature superconductor.
它和我们早期发现这个低温超导材料就不一样，磁力线可以穿透咱们这个超导材料。你要去左右移动它的时候，你会明显感觉到，就一个无形的弹簧拉着你，它就有一个回复力把你拉回去。
This special property, known as flux pinning, allows the superconductor to float in a steadier way. But what's more important, they can work in a warmer environment attainable by liquid nitrogen, which is cheap and plentiful.
然后我们磁悬浮就整个列车下面全部均布了我们这个悬浮装置，所以说它的受力相对比较均匀，对这个桥梁啊这些的要求要低一些，所以说从某种意义上说也可以降低我们这个土建的成本。
这个车因为采用了高温超导制式，它的动力全部在地面上了。原来的车上还有个电动机动力驱动了嘛，那么它就不用它了。这样的话，车就很简单，跑起来更安全了。
Outside China, maglev technology has shown sign of taking off in Japan. It set a record of 603 kilometers per hour back in 2015. A maglev line between Tokyo and Nagoya is scheduled to open commercially in 2027. But for China's maglev prototype, the real challenge is not from Japan, but from within. Since 2008, China has already paved over 35,000 kilometers of its ambitious HSR network, attaining 70% of its 2025 goal to complete its 8+8 HSR grid. Those tracks are not compatible with maglevs. It needs to survive in this high-speed real world still dominated by wheels.
它是一个有益的补充，比如说这个高温超导磁浮，它就适用于点对点旅客旅游线路，联网要求不高的。但是在点对点旅客量比较大的点上，或者在山区， 尤其西部这个地广人稀、产线工作量小的情况下，我们这个就更合适。
What's next for this super train? With Deng and Jin's team are working to extend its test track to 40 kilometers outside of Chengdu, so the 620 kilometers per hour top speed can be put to the test.
我想很久以后，这个会占一个主导，但这个漫长的过程。